Vanakkam all of you. Today we are going to see about the media and principle part 2. Okay, get into that. First media one, endo-agar, EOSIN methylene blue agar, hectone enteric agar, mechanic agar and Montel salt agar. Okay, first get into the endo-agar. Endo-agar is mainly used for the detection of fecal contamination in water and dairy products. And it is also used to isolate and identification of the enteric lactose fermented organisms as well as Salmonella typhi like lactose non-fermented organisms. Okay, first one in this picture it was shown that E. coli. In endo-agar, it forms a colony in the form of metallic sheen. And another one is, so here in this media, three type of organisms are streaked. The first one is E. coli and it is Enterobacter aerogens, Shigella sonneti. In this, see, Enterobacter aerogens is colorful, pink colored. This is a colorless one. So this is a lactose fermenter. This is a non-lactose fermenter. Okay, so we can able to differentiate the organisms by means of the colors, fermenter or non-fermenter. Okay, the composition of organism is composition of media is peptone. It is for the nitrogen, provides the nitrogen, carbon, vitamins and minerals. And lactose, it is the fermentable carbohydrate. And dipotassium phosphate and sodium sulfate and basic first chain. Basic first chain is mainly responsible for the suppression of gram-positive bacteria. And sodium sulfate and basic first chain combine to form the aldehyde reaction, that only formation of the red color ration formation. In addition, the fermentation of the lactose which leads to the formation of some pink color appearance on this media. If that organisms cannot able to ferment the lactose, means it won't produce any of the colors. And agar 15 gram and pH is 7.5 plus or minus 0.2 at 25 degrees Celsius. Okay, next one, EMB agar or EOSIN methylene blue agar. It is used for the isolation of fecal coliforms. It was very common and famous media. It is used for the detection of fecal coliforms as well as specialized media for the E. coli. See, in this, 4 different types of organisms are streaked in this plate. The first one is the E. coli and this one is the Enterobacter aerogens, Salmonella typhimurium, Enterococcus fecalis. See, in this, the metallic sheen was observed in the E. coli streak, and pink with low or dark color formation and slightly purple color formation was observed in the Enterobacter aerogens. There is no color formation observed in the other 2 organisms. Okay, this is due to the formation of the fermentation also. Okay, so there is no color formation was observed. Okay, sometimes the E. coli appeared in the black color formation also. So composition of the media is peptic digest of animal tissue. It provides the carbon, nitrogen and essential nutrients. And dipotassium phosphate, it possesses the lactose, it's a fermentable carbohydrate, and sucrose, it's also a carbohydrate. And EOSIN, why? It suppresses the growth of gram-positive organism. And methylene blue, it is indicator which convert the colors in the acidic nature. It forms the dark purple complex with greenish metallic sheen. So agar 13.5 gram and pH is 7.2 plus or minus 2 at 25 degrees Celsius. The pink color formation also observed. In this special, if the organisms is very good nature of the lactose fermenter and utilizing this media, means it forms the greenish metallic sheen, whereas the lactose fermenters forms the pink color. Non-lactose fermenters forms the colorless colonies. So we have to clear in this concept. Okay, next one, hectone enteric agar. So this is mainly for the isolation and differentiation of Salmonella and Shigella species. See, in this, the 4 different organisms are streaked. The first one, E. coli, and Proteus mirabilis, Shigella flexneri, and Enterococcus faecalis. See, the fermentation takes place, so it produces the yellow color colonies. So, whereas the Proteus mirabilis does not ferment the lactose, but it forms the black precipitate by means of the reaction of sulfur reduction. So, Shigella is a non-lactose fermenter, so it forms the blue-green color, and it also not a sulfate reducer, so it cannot form the black precipitate. And Enterococcus faecalis is completely inhibited by means of the bile salts present in this media. So next one, here the Salmonella typhimurium and E. coli are in the same plate. The black colonies are the Salmonella. Due to it can able to reduce the sulfur and it forms the black precipitate. And E. coli can able to ferment the lactose and final product which makes the colors. So yellow color colonies are the E. coli and black color colonies are Salmonella typhimurium. So coming to the composition, it possesses the protease peptone and yeast extract which provides the carbon, nitrogen and the essential nutrients for the organisms, and lactose, sucrose, salicin. These three are fermented by means of the organisms and reduce the sulfur, and reduction of sulfur leads to the formation of hydrogen sulfide gas, whereas this H2S gas combine with ferric ammonium citrate and finally forms the black precipitate. So the organisms can able to reduce the sulfur only can form the black precipitate in this medium. So Salmonella typhimurium have the capacity to reduce the sulfur present in this media and forms the black precipitate. And moreover, the E. coli forms the yellow color because it can be able to ferment the lactose present in this composition. And bile salts mixture, okay, it's a very important one in this. It inhibits the gram-positive organisms. Okay, and sodium chloride. Sodium chloride is the normally NaCl. It is mainly for the osmotic balance. And sodium thiosulfate. This is a source of sulfate, and ferric ammonium citrate. Okay, already we have seen this role. The H2S formation is combined with the ferric ammonium citrate and forms the black precipitate, which indicates the particular organisms. And acid fustian, bromothymol blue. Acid fustian is a color indicator, and bromothymol also a color indicator. Agar 14 gram and pH 7.5 plus or minus 0.2 at 25 degrees Celsius. Mechanical agar. Mechanical agar is mainly used for the isolation and differentiate the members of Enterobacteriaceae. So if we are using the mechanical agar without crystal violet, we can detect the gram-positive organism also. Gram-positive cocci especially. So in this we can see the clockwise direction. This is one E. coli, Enterobacteria aerogenes, Shigella sunnet and Proteus mirabilis. See, these two organisms can able to ferment it and produce this color colonies, and this it's non-lactose fermenters, so they remain there, so colorless forms. So compositions: peptone, pancreatic digest of gelatin is a carbon and energy source, and protease peptone also. Lactose monohydrate is the fermentable carbohydrate. Bile salts, it inhibits the gram-positive organisms. Sodium chloride for the maintenance of osmotic balance. Neutral lead and crystal violet are pH indicators. Agar and pH is 7.1 plus or minus 0.2 at 25 degrees Celsius. So next one, mannitol salt agar. Mannitol salt agar is mainly for the isolation and differentiation of pathogenic staphylococci. See, especially Staphylococcus aureus. So here see, there are two types of Staphylococcus organisms are there. This one is the Staphylococcus aureus. This one is the Staphylococcus epidemidis. Okay, this one forms the normal pink color. This one forms the yellow colors. So this is one is the pathogenic one. The both organisms are streaked in this. See, yellow color colonies are formed by Staphylococcus aureus, whereas the small pink color colonies are formed by the Staphylococcus epidermidis. And then composition of this medium is pancreatic digest of casein and pancreatic digest of animal tissue, beef extract, just act as a nitrogen and vitamins, minerals and amino acids source for the growth of the organism. Sodium chloride, okay, it is for the osmotic balance. And D-mannitol is a fermentable carbohydrate, phenol red indicator, and organism which ferment the mannitol and produce the yellow color colonies with some of the halos. Halos means the outside also, around the organism also there is a halo zone which forms the yellow color, okay, that can able to formed by the organisms which can able to ferment the mannitol. So agar and pH is 7.4 plus or minus 0.2 at 25 degrees Celsius. So the reference is the same one, the wonderful book, A Photography Atlas for the Microbiology Laboratory, 4th edition, Michael J. Loffey, Burton A. Pierce. So if you have any doubts regarding this, and if you want any of the topics or else you want to know about any other mediums, just let me know and mail me at sivastan91@gmail.com. You can ping me at any time. Thank you.